Hi there, in this video you're going to learn about how to compare populations. Your objectives for today are to compare two populations using the measures of center and variability, and to compare two populations when only one is symmetric. Let's start with what a box plot is. A box plot uses a number line to show the distribution of a set of data. It divides a set of data into four parts using the median and the quartiles. A box is drawn around the quartile values, and whiskers extend from the quartiles to the max and min that are not considered outliers. A double box plot consists of two box plots graphed on the same number line, and you can draw inferences about populations by comparing their centers of variability. So let's look at this. This is a double box plot here. Casey surveyed a group of students in her science class and in her math class. The double box plot shows the results for both classes. Compare their centers and variations. Write an inference you can draw about the two populations. All right, so how many times have you posted a blog this month? So in math class, the median is 10 times. You see how the middle of the box plot is 10. So that's the median, okay? Your Q1 is 5. Your Q3 is 20. These are what they call the whiskers on either side, the lines that extend to your minimum, which is 0, and your maximum, which is 30. Okay, let's try to read the science class's box plot now. 20 is your median, your Q1 is 15, your Q3 is 25, your whiskers extend on either side, your min is 0, and your maximum is 30. So, neither box plot is symmetric, so we're going to use the median to compare the centers and the IR to compare the variations. So I'll get into talking more about symmetric and not symmetric in the next slide. But for now, let's just compare their medians and their interquartile ranges. So your median for the math class is 10 times, okay? And your median for the science class is 20 times. Your IR, if you remember from the lesson before, is Q3 minus Q1. Q3 minus Q1. So you have 20 as your Q3, 5 as your Q1. 20 minus 5 gets you 15. 25 is your Q3 here. 15 is your Q1 here. You do 25 minus 15 to get 10. Overall, the science students posted more blogs than the math students, right? 20 students versus 10 students. The median for the science class is twice the median for the math class. There is a greater spread of data around the median for the math class than the science class. If you notice here, the data is spread out more than it is for the math class. The data here is spread out more. So if you look at the interquartile range here, it's more spread out than the interquartile range here. So that's how you know which has a greater spread of data. Just compare their IRs. All right, so this is dot plots. Now we're going to talk about dot plots, and we're also going to talk about symmetry. Okay, so here, neither one were symmetric. If they were symmetric, you'd be able to fold them in half, and you would be able to fold them where the median is. Both rectangles would be the same length. Both whiskers would be the same length. Okay? So in this case, neither box plot was symmetric because you can't fold both of them along the median and then have them, directly go one on top of the other. Okay? Same thing with dot plots. When both are symmetric, you use the mean and the mean absolute deviation. When neither is symmetric or only one is symmetric, you use the median and the IR to compare. Okay? So these rules apply for both. So these rules apply for both box plots and dot plots. Okay? So when both are symmetric, use the mean and the mean absolute deviation. When neither set is symmetric or only one is symmetric, you use the median and the interquartile range to compare. Okay? So here, neither was symmetric, so we use the median and the interquartile range to compare. Let's look at our next example. The double dot plot below shows the daily high temperatures for two cities for 13 days. Compare the centers and variations for the two populations. Write an inference you can draw about the two populations. Okay, so here are the daily high temperatures for Springfield and for Lake City. If we notice, it looks like both of these are symmetric. If you notice, there's 3, 2, 2, 2, 2, 1, 1. Okay, if you were to fold this graph along this middle right here, okay, all the dots would be one on top of the other. Same thing with this. If you were to fold this dot plot along this line right here, you would be all the dots would go one on top of the other. Okay, so following our rules, when both are symmetric, you use the mean and the mean absolute deviation. Both are symmetric, so we're using the mean and the mean absolute deviation. Okay, so let's look at Springfield first. Springfield's mean is 81, and you have to just add 78 plus 79 plus 79 plus 80 plus 80 plus 81, 81, 81, 82, 82, 83, 83, and 84, and then divide, right? And then you would have to divide by the total number of dots on the dot plot, okay, to get your mean as 81. Your mean for Lake City, you do the same thing. So add 81, 82 plus 82, 83 plus 83, 84, 84, 84, 85, 85, 86, 86, and 87. And then you would divide it by all the dots that are there, okay? So you would get your median to be 84. From there, you would have to go through all that work that we went through in the last video to find our MAD. In other words, subtract 78 minus 81, get the absolute value. 79 minus 81, get the absolute value. 79 minus 81, get the absolute value. 80, okay, so you just have to keep going through it until you get the MAD. Once you get your MADs, you can compare those two. So for Springfield, the MAD was 1.4, and for Lake City, the MAD is 1.4. So while both cities have the same variation or spread of data about each of their means, Lake City has a greater mean temperature than Springfield. So see, Lake City has a greater mean than Springfield. Overall, Lake City had a warmer climate than Springfield during the period that the data was recorded. Only one symmetric population. So you can compare two populations when only one is symmetric. The mean and the median of symmetric distribution are very similar, if not the same. So you can use the median and the IR, okay? So when you're comparing populations and only one is symmetric, you're using the median and the IR, okay? Again, when only one is symmetric, use the median and the IR to compare. Write these two rules down, please, so that you know them and you don't ask me which one you're supposed to use. I don't know which one you're supposed to use. Look at the rules, okay? If they're symmetric, okay, you're using the mean and the mean absolute deviation. If they are not symmetric or only one is symmetric, you're using the median and the IR. All right, so here is our next example. The double box plot shows the daily participants for the two zipline companies for 1 month. Compare the centers and variations of the two populations. Which company has a greater number of daily participants? Okay, so here, right away, I could tell you these two are, actually, this is symmetric because you can fold it down the middle here, okay? This one is not symmetric because if you fold it down here, one is not going to directly lay on the other side. By the way, this star here represents an outlier, okay? All right, so the distribution of zip adventures is symmetric, right? While distribution for treetop is not symmetric. So use the median and the IR to compare. So our median for treetop tours is 70. Our median for zip adventures is 50. Okay, your IRs, you're going to just do Q3 minus Q1. So to get 30, and same thing down here. Q3 minus Q1, you get 20. So overall, treetop tours have a greater number of daily participants. However, treetop tours also has a greater variation, so it's more difficult to predict how many participants they have every day. Zip adventures has a greater consistency in their distribution because they are symmetric. Concluding thoughts. So just when comparing, it shouldn't be dot plots, it should be anything. When both are symmetric, you use a mean and mean absolute deviation. When neither is symmetric, you use a median and the interquartile range to compare. All right, thank you for watching.